All right, we'll get started. I feel like this is not what I originally set this to.
Oh, yeah.
It's better, zoom in more.
Yeah.
I'm planning to spend a block on it.
Did you check out?
Oh, I got it.
Okay, so announcements before we get started. My goal before Thanksgiving has been to have a couple people come talk in this class from industry. One of them is an Eastern graduate from almost a decade ago, and the other is a Microsoft employee who's had his hands in a bunch of Azure and Xbox development, as well as he's really cool. So I finally scheduled the first of these. They finally knew enough about their work schedule, which is great. So I already forgot the exact date, but it was, yeah, November 12th is going to be the Microsoft employee coming and talking. I sent them a list of interesting things to talk about because at this stage in your education, I feel like it is very important to know what you can be doing to prepare yourself for that job hunt. You don't want to be starting that process after you graduate because there's a lot to do, and it's easier if you're thinking about it the entire way. At the end of each quarter, think about what can I put in my code portfolio? Think about what kinds of internships can I be applying for? What do you need in order to do all of that? So there will be some talks aimed at the industry experience. What do they do? How do they use some of what we've been talking about in class, as well as time for questions about what does the industry look like right now from a few different perspectives. So that is coming. It's something that I find to be really important in classes like this, leading up to your capstone, as you pick your electives, as you work towards graduating, because the whole purpose of being here is to jumpstart your career, right? At least I like to think so. So that is coming. Put it on your calendar. You want to be here for it. It should be in person since they work remotely from Spokane. So that would be really nice. I'll try to get the other one scheduled as soon as possible, as soon as I know more about their work schedule. And let's see. Other than that, I don't think there are a ton of announcements. We have our client demo tomorrow. Sprint 2 is due on Sunday.
This Sunday?
It's Sunday.
Oh, good.
Yeah. We fly through these. We have 4 sprints planned, and this is going to be the end of Sprint 2. Let's see, is there anything else that I am not thinking of? I don't think so. We had a quiz yesterday. I know nothing about it yet. Next one will be for a little while yet. And I think that's basically it. So we are through all of the required content for Sprint 2. Everything technologically that I'm asking you to do, we have either covered or I'm having you do some research on. When there are 5 or 6 of you, something like, how do I GUI? I assume people can, for the most part, figure out how to do the basics of it. So I want to start talking about one of the required directions for Sprint 3. And as I have taught design patterns last winter and spring, I have found that, one, I hate the course, as I'm sure most of you agree with. The course is just straight up in the wrong place in the curriculum. And the reason that I say this is that I can talk about design patterns at that level in the abstract. And that's about it. You don't have any experience with larger scale applications. So when I say this promotes scalability, or this is why, it falls on deaf ears, because it's not your fault. You don't have the experience to make that connection yet. And it makes so much more sense to me for them to be in this class, because you have created your own large project from scratch. There's no starter code that I'm giving you that you have to understand and analyze, and it wasn't written by you or people like you in this class. When you are making this UML editor, you are in charge of that entire development. You know your code. If you don't know your code, you know someone who knows your code. They're in your group. So I want to revisit design patterns ahead of sprint 3, because now at this stage, we can actually have a meaningful discussion about them. For each of the patterns that we go over, we're gonna start thinking about how could this be applied to this project? Where would it make sense to apply this pattern? What would the benefits and detriments be to the scalability of the project? What would the benefits and detriments be to future coding for this project when we talk about this pattern? And to me, this is a much better way to talk about design patterns. These aren't abstract concepts that are applied abstractly. They are abstract concepts that have real applications to code that you need to have in front of you to be able to really think about them. So I'm hoping that this is a good refresher. What I wanted to query people about ahead of getting started with this is I like to do thumbs every once in a while. If I asked right now, without referring to too much outside content, if I said, put 6 design patterns into your existing UML editor, who would feel confident? I could do it, it would take a lot of work. I don't really even know where to start. Where in that process, where would you feel about that? I see very few thumbs up, which to me means that we need to revisit this. We need to talk about the application, because regardless of who you took it from, I see my own students having this as well. And again, that just means that it wasn't able to be applied at that level. So I think it's worth revisiting and applying because they're important. They're used in industry. So let's dive into it a little bit. I don't have any slide deck for this, so I'm really just gonna go through Refactoring Guru. I know that those of you who have taken this, at least from me, have seen at least one lecture where all we did was go through Refactoring Guru. So I kind of want to follow up on that, go back through them, remind ourselves the purposes of these patterns, but also have that class discussion about where they belong. Let's start with the classes of design patterns. So there were 3 of them: creational, structural, behavioral. Can someone describe the difference between those? What is the purpose of a creational pattern? What is the purpose of a structural pattern? What is the purpose of a behavioral pattern? Let's start there. Yeah?
Behavioral pattern define.
That's a good start. Using the word to define itself, I like it. That's not a criticism, but it's a place to start. It defines behavior. In what sense? But what does behavior mean in the scope of a design pattern? Yeah?
How it interacts with the rest of the program, or how it, it looks or operates during runtime.
Yeah, so I like to think of them as algorithmic. Usually the behavior refers to some kind of process and making a particular kind of process scalable. If that means that you can swap out those processes. So I think that just about everybody in here, your first pattern that you saw was the strategy pattern. Is that right? Is that usually where people start? So strategy, the concept of strategy was just having an algorithm that you can swap out for another algorithm. If you took data structures from me, the example that I used here was, let's say we have a linked list interface and a number of different kinds of linked lists that implement that interface. So we have a singly linked list, we have a doubly linked list, we have a circular linked list, any other kind of linked list that is an implementation of this. Embedded in those files, we want to be able to sort these linked lists. But of course, there are many different kinds of sorts. How do you want to sort your singly linked list? Do you want to use BOGO sort? No, the answer is no. You do not want to use BOGO sort. The lack of laughs telling people don't remember what BOGO sort is. Randomize the algorithm, randomize the order, check if it's in order. Randomize the order, check if it's in order. Randomize the order, check if it's in order. I use it as an example of a factorial time algorithm. It's disgusting. You could use any of these slower sorts. So insertion sort, selection sort, bubble sort. You could use a more complicated but better sort, like merge sort or quick sort. any of the sorts. The idea is that we could take these algorithms and put them to the side and write them, assuming we had a linked list, but which one are we actually using at runtime? That could be embedded inside of a strategy pattern that says we're gonna make a sort object that then defines which sort behavior is used. We will compose the linked list of a sort behavior. And then how we actually sort that linked list is just however we instantiate that object. We would have a sort behavior, new sort behavior equals behavior equals new sort behavior, selection sort. And that would use the selection sort class in that place to compose that object to say, when we sort this singly linked list, we're going to use the selection sort algorithm. So I guess we can start just with the actual strategy pattern. But so that's it's better use of the strategy pattern inside of something that you've probably seen before. So we have, I don't know, I don't even necessarily like everything that's in here as much as that example, because it relates in a way to something that I know all of you have done in the past. So a refresher on what Refactoring Guru can do is it tells you, here's the issue. It tells you, here's the solution. Here's the intuitive idea behind how to solve the problem. Some kind of real world analogy. This just represents an algorithm. How is it that you're getting to the airport? Do you use the I'm going to bike to the airport algorithm? Do you use the I'm going to take the bus algorithm to the airport? Or do you use the algorithm I'm going to take the taxi to the airport? It gives you some UML structure. Now that we have some experience with UML editors, these should become significantly more readable. Anyone recognize any of these arrows or any of these symbols?
Aggregate, we have some dependencies, then we have triangle boy.
Yes, we have some generalization here, right? We have some inheritance hierarchy where we're implementing an interface, but it's not a straight line, it's a realization. So we have kind of a realization generalization that says this is what we use for implementing an interface, rather than having a superclass and a subclass. All right, we have some pseudocode for how to do that. And then the most important thing at the very bottom is the code examples in every single useful language that I can imagine you using in this class. So most of you will click on Java and one group of you will click on Python. And regardless of what you click, you can see the actual example of what this looks like. So where in our project could we apply something like the strategy pattern? Are there any algorithmic processes within our UML editor that could be swappable? How's your code structured? How does that, what processes exist in general? What algorithmic processes exist?
If there's any like strict algorithms, like there's no sorting of it.
Right.
So yeah, so I don't think it really fits in very well.
Yeah, so strategy, at least in its current form, I would argue as well, there's not something that is an obvious application of the strategy pattern. But this is the kind of thinking that you might want to use if you were, say, required to implement some number of different instances of design patterns in the reasonably near future. You could try to go through this process. So I just wanted to give you the one that you've probably all seen and hopefully understand the best to start with for that reason. So we talked about behavioral patterns. What about structural and creational patterns? A lot of structural patterns. In general, what is a structural pattern? How would you group those patterns together? In fact, I'll reveal the ones so that maybe you can see here on the left what it's sitting right in front of it. Here are the patterns. What do they share in common if you remember these patterns from 212?
Kind of shared like building out objects. Such or like,
Yeah, so the structure of objects and how objects interrelate.
yeah,
Yeah, absolutely. So I like adapter. It's very simple and straightforward as an example of a structural pattern because we want to be able to interact with something that we are not natively able to interact with. So we need to construct an adapter to allow the communication between components who aren't necessarily built to communicate.
Subconscious, we're looking at.
Right?
Am I taking a car on a rail instead of a train?
So if they don't have compatible interfaces, then we could have some kind of collaboration between them. Does this make sense in our project? Where? But for those of you who are nodding your heads, what makes you think of an adapter?
I think we already started with CLI interface, adapting the GUI to it.
Yeah, so something like adapting the GUI to the CLI, there'd be some kind of conversion algorithm that says, when we go to output something in the CLI view, right now we've hard coded that idea. If we wanted to convert what the GUI needs, maybe we take that same feed of information and we divert it through an adapter that's gonna add in the associated content that we need to be able to take that existing function and use that as output for a GUI rather than writing a separate one. I would argue that after implementing MVC, that's probably a terrible idea. Because that was the entire purpose of MVC, right? Was to be able to just swap out views. And we want the model and the controller to stay exactly the same. So if we put an adapter in on top of that, we would either be designing the MVC incorrectly to need the adapter, or, well, that's probably the main reason. So while adapter could be used, I don't know if it's the best one, or if you want to use adapter, it probably means that you've done something else that should be fixed. So yeah, structural pattern has to do with the structure of objects and the connections between those objects. So algorithmic, how do objects interact with other objects? Or what objects are used? Structural, and now we're going to talk about creational. What are the creational patterns? We covered just about all of these. We did cover all of these in my 212. So what do they do? What are they for? What's the purpose?
No, just to put it in not plain words. Probably say creational design pattern provides various object creation patterns. Increase flexibility. Just a. Dude, that was fun. Thank you.
We know how to read at the college level. I love it. That puts a nice baseline.
Now to try to paraphrase. Wonderful statement.
Yeah, what does that mean?
Basically, creation of objects during runtime.
Yes.
How do we generate things within it? To use a very fun example, factory is super great because that is exactly how goblins are made in video games. There's a factory function that's creating a bunch of different goblins with different stats in your RPG.
Yeah, you did not take 212 from me, but I did exactly, I used that exact example of D&D character creation when talking about some of the patterns. I think it was mostly prototype, but D&D works very well for a lot of these design patterns because it's a reasonably complicated thing. But yes, creational design patterns get around some of the issues surrounding object creation when you have a large and scaled application that a lot of issues crop up during. So factory, for instance, allows us to create different kinds of objects based on their eventual use when most of that creation is the same. So the basic idea, exactly as it says up here. So we have some way to create objects in a superclass, but the subclasses need to be able to override the type of object that's being created to allow for whatever that subclass's purpose is. We're gonna take this generic idea and we're gonna modify it to make sure that it can float or that it can drive in this case. But there's still cargo. Exactly what you're creating is a cargo container, but it's a cargo container that floats or a cargo container that drives. The underlying class of which is different, but it would inherit from the same interface. Is there a place that we can imagine using factory in our project? What gets created? What are the kinds of objects that get instantiated? Classes? What are the different kinds of classes that we might be able to make? Is there an equivalent of a floating class and a driving class? What would that look like in the scope of our project? Yeah, maybe we could have two different kinds of classes that a user might want to create. Maybe you also could have some options about a default class with just a name that the user might fill in the fields and methods for. There might also be a process associated with filling in those fields and methods on creation. So now we have two different classes with different amounts of work that's done in the constructor. You could overload the constructor. You could make a factory. Why would you choose one or the other? When would you just want to overload the constructor versus when would you want to actually apply the factory pattern?
Overloading is generally when there's one separate instance, when you want to be a little bit more specific.
Yeah, we need to know at the class level. Are we making this kind of object or that kind of object? The factory is useful when we have those subclasses, and this subclass number 1, wants to instantiate an object in this way. And subclass number 2 wants to instantiate an object in that way. Do we have that kind of structure? Maybe. Do we know on creation if there are two different kinds of buttons? Create empty class, create class with details. If you had that kind of implementation in your GUI, then maybe you want a factory. When you click one button, that's going to instantiate a subclass that calls a constructor in a certain way. So maybe there is a place for factory here. Something worth considering. What other patterns do we think are going to be useful here? I wish I could expand all 3 of these at the same time. Thoughts?
First off, singleton, because it'd be nice to have one diagram open during the program at all times.
Yes, that's a very good idea, to be able to ensure. So singleton is useful whenever we want to ensure that we only have a single object instantiated at a particular time. We want to make sure that, for instance, a GUI, there's a single window pop-up. You don't want to be able to call the constructor for that window and produce an arbitrary number of pop-ups. Unless you want to be working on multiple different UML diagrams at the same time, have each one tied to a separate instance of that class. Maybe that's something that you want eventually. But in the meantime, if we only want there to be one, then we could apply the singleton pattern to it. Absolutely. This one was nice and simple, but do remember that we have a very important, I don't know if this goes through it, but you want to make it thread safe. This doesn't go through it a ton. Why not? Since I've taught this class now, the last time I taught this class, I hadn't taught 212 before, but now I have lots of slide decks on these. So maybe I'll upload all of those to our Canvas, just so that you can get a sense of what are all the patterns that I cover historically in my design patterns, and you can use that as an additional reference on top of Refactoring Guru in case you want to go look at that. So I'll get that up as well. So singleton, intriguing idea. Any others that could be useful? What are other design patterns here that we recognize? What have we seen before? What have we done a lab on?
We have to do decorating pattern.
Yeah, we can talk about decorator. What's the decorator beyond being exactly the words that are on the page or this beautiful illustration of a Russian doll? What does decorator do? Yeah.
Implementing in Java is a little bit of a pain, but basically it's a bunch of class wrappers you put around an object that are all the exact same instance of that class. So no matter what, you can always rip it out. Like a tree, it has ornaments. Instead of having a bunch of different variations of a trees and trying to track all of those dependencies in very gross class code, you just kind of implement in that interface where it's decorating that class, saying, here's all of the stuff on it, and the parentheses can get really gross.
Yes, so if we want to be able to attach something to a base object, it can be behaviors, but it can even be, I guess, we use the example of ornaments on trees as a good example of, that's a component of it. We can wrap it with a component of it to change the inherent behavior of it. So we now have a nested structure, a structure defined in terms of its components. What were some of the issues with using decorator? We found that we only had access, for instance, to the outside, the outermost object. If you wanted to find what the base object was inside of it, you had to go through a long chain of composition to say, you're made up of this, which is 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 not made up of anything, therefore it must be the base object. Oh, it's a tree. Whereas when you walk into a room, for instance, and you see a decorated tree, you, the human, goes, oh, that's a tree, and it's a really easy question to answer. Programmatically, if you design it as a decorator, trying to figure out what it is and its base form is really tough. It's like a box inside of a box inside of a box. I got a present. What's the present? Another present. Another present. Another present. Oh, it's a rock. My parents really wanted to give me the biggest gift, but they just took a random rock from outside, put it in a box, put that in a box, put that in a box. To figure out that it's a rock, you have to open up a bunch of presents, which is a bunch of work.
It's super nice when you don't need to know what the base object is.
Right.
Like an example for it that I went through when I took 212 was, if you were just like to create, if you're getting an order from someone and you're a barista, that software is super nice because I don't need to know precisely it's a coffee with the caramel macchiato frap whip. I just need to know, okay, enter that in, here's the price for that.
Right.
It handles that. It adds that decoration, says, oh, the price of this is now this.
And even if you wanted to convert that into an algorithm that says, prepare this drink, you don't need to know that it's a coffee in order to add the caramel, in order to add the whip. You just start with a cup. If everything starts with a cup, you just start putting the stuff in the cup. And eventually, assuming it all gets mixed together, it doesn't matter the order.
Now it's just, okay, which base is it? Tea, is it coffee, or is it water? I don't know why they do that, but you can do that.
But it starts in a cup. Regardless, it starts in a cup. So as long as you have that baseline of what do I go start with, then the order doesn't matter. Yeah.
Like just on top of that, like it could be the idea that like, oh, the base object inside is just a useless piece of paper, but all the different layers that are put together is different boxes, like it's a Christmas present on the outside, but then you open the first layer, it's just wrapping paper in a cardboard box, and you get the next layer, it's a harder box covered in zip ties, and then you get the next layer, and it's
a tree.
duct tape.
But yeah, that's exactly right. You can add kind of embellishes to each of those different types. And as long as they adhere to the same hierarchy, the same class hierarchy, then you can instantiate any one of them as one of those subclasses. Yeah, exactly. It's a great point. Still a tree though. Inside of that, at the very bottom, it's a tree, which explodes in size. Anyway, how could this be used in our project? Is there anything that seems like we have a decorator type of?
I guess like how the class stuff, like how classes have methods and that work, that my right there.
That's a possibility, just having done it myself, it seems a little gross to wrap it all in that. Because at the end of the day, a method is different from a class. And sure, it implements it, You could,
What if you had, this is a really strange structural idea. We have a class object. Class objects are composed of methods and composed of fields. We know we kind of have these two structures. Right now, they're stored as some kind of list. What if they were stored as a decorator? What if you had a field wrapped with a field wrapped with a field wrapped with a field wrapped with a field? What if you had a method wrapped with a method wrapped with a method wrapped with a method, and we composed a class of these two things? Is there any reason that we should consider doing that? Jimmy, no. How does it become searchable? You have to start opening all of these presents to try to find them one at a time. That's kind of how we work as a linked list though, right? We iterate from list element to list element to list element. Is it any harder to digitally unwrap something than it is to follow a reference to the next object?
I mean, Java, because then you have to dot this, and then it's very dependent on how much you dot that of how many objects are in there versus a list. I can always just do size of and iterate through it.
I give this as an example to show you an example of not an applied design pattern that would not be good. If I see something like this, I will say, you did this in order to fulfill the number of design patterns requirements, but functionally this serves no purpose. This is strictly worse design than just using a list. So is there any other place that might reasonably involve a decorator?
A lot of things outside of this project.
Yes, it is a design pattern and is used because there are great instances of that being put together. But here is an example of different kinds of notifiers. We have a base notifier, we have a bunch of different kinds of notifiers. If we needed to now stack different kinds of notifiers on top of each other.
Now, make a lot of different notifiers.
So one place that this may make sense is actually in the creation. If, for instance, you were trying to allow for, in your design of, I'm gonna want to add a bunch of methods at the same time, and I don't want them to appear as I'm typing them. I want to store a single object that is all the methods that are part of this object's creation. As part of the factory of designing this object, I could wrap the user's requests for a field and a method. When they say, I want a field, I want a method, wrap that up as one object, and then you could pass it by reference. Rather than trying to pass a bunch of different objects or a bunch of different object references, it becomes a single object reference that gets passed when we want to deconstruct that and actually make the object before we push it to the view.
So you just parse the requests.
Yep, you could just parse the requests. That is a simpler idea. But if that would adhere to something like this, and again, I don't think it's the right design, but there are places for critical thinking about, does it make sense? Does it help the scalability of this program? Does it allow me to create something different and minimize the amount of code refactoring that I would need in order to make this work? That is where the intelligent designs are going to come in these design patterns. So maybe I can get a suggestion from someone. What is a pattern that you can see applying? What would help us to be able to scale this program in some dimension in the future, whether it's a requirement right now or not? How can we design something for scalability for additional requirements? First of all, how could this application scale? We have a UML editor. Imagine that this is eventually, we only have 10 weeks in this class, but eventually we want this to be the bomb diggitiest UML editor in existence. To have that functionality, what does this UML editor do? How is it scaled from this requirement? I talked to a couple of teams about this in our last lab, talking about design, but something like allowing real-time interaction between a bunch of different people editing the same UML diagram at the same time. So I open up the UML editor in command line mode. My teammate opens up the UML editor in graphical mode, we're going to collaborate. I'm gonna add some classes, they're gonna add some classes, and in real time, everything that we do is updated in each other's view. And then when we go save or load, it's gonna save the changes made by both of us. Or load the changes made by both of us. What kind of functionality would allow for that kind of scaling?
GitHub.
Yes. But I wouldn't be able to see it in real time, I'd have to request the update from the cloud. Those instances are not directly tied or connected to each other. That would be pretty cool. What would the structure of that look like? Now we need multiple instances, we need communication between those two instances. Whenever a change is made one place, it's pushed to the other, and vice versa. But that's not the only way to launch the application. So is there a creational pattern that might allow us to be able to launch the program in single mode versus launch it in paired mode? The reason that I'm doing this is I'm trying to get people to think, I don't want to spoil all of these Sprint 3 requirements, but when you get the Sprint 3 requirements, I want to demonstrate the process of, here's the requirement, how can I add that level of functionality for scalability? Not just to meet the exact requirement for what I need to have at the end of this sprint, but in case I wanted to go back and modify this in the future. In case this were going to be the baseline project for some company's future development. Thinking from that scalability perspective. What other patterns have we covered? What other patterns do we know might apply here? Any of these that we've seen that we know?
I feel like prototype could be used for like something like.
Yeah.
say,
Yeah, so prototype. Let's talk about it. What was prototype?
Making like a exact copy.
Yeah, we start with kind of a baseline object, and then we're going to copy that and then make the last few changes to that object on the fly. So we can copy objects without being dependent on what they are. So we start with a baseline. I love this, by the way. I say that every time I go into this, but can we copy this plane? If we're looking at it from the outside, we don't really understand the inner workings of it, right? So we come up with the best outside representation that we can, but does it have the internal functionality? No. Do we actually think that this plane made out of sticks flies? Probably not.
Could make a stick engine.
Probably not. But we could have, note that this is also very relevant to security. We don't want anyone to be able to clone and make objects of this particular type. They have to go through a particular process. So you can put in the request for the object to be made, and we pass you, all right, here's the bare bones working representation, but I kept the process of that creation separate, or so that you don't understand how it works. But here you go, embellish it how you want. So we don't necessarily want to be able to copy an object from an outside perspective for security reasons. So we add the functionality to clone that object. That is a private method, which means that only an object knows how to create a copy of itself. I don't even know how the process works. If a clone of me walks through the door, I'd be like, yes, you're an exact clone of me. What happened last night? How do you exist? I don't know the process, but I'm able to verify, sure enough, that is a clone of me. So the code representation of this is just that we have a private method that is going to create the clone and return the clone. And now we want to have the ability to take that created object and do whatever we need to it. But from the outside perspective, we don't need to know how that process works. Does that seem like it might be useful in our project? I would argue this could be super useful to get a bare bones class without particular fields or methods, or to get particular kinds of classes. If we wanted to have a database of pre-existing classes, I want a class of this type. Then we could do a lookup for that particular type, have it algorithmically determine how do we make a base model of this particular kind of class, and now we'll return that. To say, I don't know exactly what these fields and methods are going to be, but we've instantiated the appropriate numbers of fields and methods of the associated types. For instance, maybe I want to overload a method, so I want to start with an existing copy of that object. So I could clone the method and then just specify the changes to the method rather than trying to define it from scratch. That seems like that could be useful. If I wanted to, is there any reason that you want to make copies of any existing classes? Copies of existing fields, copies of existing methods, copies of existing class boxes? Yeah,
So that's what I had to do to be able to list all the stuff and display all the stuff while following MVC. Is I had to request a copy of the data and then parse that data in the view instead of just calling the data from the view like we were before.
Yeah, whenever we have an object that could be cloned, we want to be thinking about prototype. There's one other instance that I can think of where this might be useful. If you're in a particular inheritance hierarchy and the relationships of a particular subclass are exactly the same as the relationships of another subclass that adhere to it, you both inherit from the same superclass, then you could copy that class's relationships rather than having to redefine them from scratch. That seems like that could be useful. So implementing clone wherever that works, now from the outside perspective, you don't have to specify it, you get a base object that is this class is created, it doesn't have a name, but it has relationships already created for it that start as a copy. So you could start from, take this class, copy the relationships, take this class, copy the fields and methods, take this class, all of those are prototypes. All of those are different kinds of clone. You could implement this design pattern for it. Other examples. Where else could we go with this? Any other structural patterns? Did we talk about too many of these others in 212s that weren't mine? I at least briefly went over them. Bridge? What was bridge?
I don't think I heard about a bridge.
Over adapter.
Yeah, we talked a bit about adapter. That's mostly used in industry for connecting legacy systems. Because in full development for this, you're gonna have total control over all of the implementation. So there isn't really a reason that you need an adapter to connect to a component that you don't have access to, because you have access to everything. So you could just go modify the original to accept that kind of connection. The example that I use for this is a plug in a house. You buy a house from 150 years ago, they don't have 3-prong outlets, they only have 2-prong outlets. So you'd need an adapter to be able to plug it into the wall. But with your code, you have access to the entire house's structure. You could go change that to be 2-prong outlets and 3-prong outlets right next to each other. Or 3-prong outlets that accept 2-prong connections. You have the ability to go do that. Only in systems where you don't have access to that would you really need an adapter. So bridge was this concept of expanding numbers of subclasses based on the example that's used in Refactoring Guru is shape and color. Now we have kind of a tuple of shape color. We're looking at the number of combinations that we could have. So if you want to be able to produce and specify on creation a shape and a color, then you would need a number of constructors or a number of subclasses to this shape that are equal to the number of possible combinations of shapes cross colors, using the concept of cross product there. As you do this, every time you want to add a shape, you have to do the shape for each color that exists. Every time you want to add a new color, you need to add that color for each shape that exists. And you get an arbitrary number of subclasses. Instead, you can use composition and say that a shape contains a color. And now instead of needing to define both of those at creation, we now can create a shape. And later, either as part of the constructor, specify the color, which has to be one of the number of colors, or we can wait on creation and say a shape can exist without a color. And then you can add to that after creation to specify the color in some kind of setter.
The good old classic texture error pattern.
Yes. So this is just whenever you need to abstract away from trying to make a large constructor. You wanna make that as small as possible now and make sure that it's contained of that so that you don't need to have as many different subclasses. Is there a place where that might make sense? Do we have a structure where we might have a bunch of different kinds of subclasses? Yeah,
The typing for all stuff, especially relationships.
relationships. Yeah, a class has a relationship. So instead of being able to specify the different kinds of classes that you might create, each of them having different numbers of possible relationships, thinking about that as a composition, I'm hoping that it's already a composition. Where I really see this applying is if you went down that prototype route and you had a bunch of different possible different base class types. I have the one field, one method class prototype. I have the two field, one method class prototype. I have the one field, two method class prototype. Rather than specifying that and trying to come up with all of the functionality for all of that, that would be a ton of different subclasses. You could compose a class of its type, then fill that type on creation via prototype in a way that would use bridge. We find this a lot in design patterns. By implementing one design pattern, you can make that design pattern's implementation easier with another design pattern. And you get a long chain of this design pattern uses that design pattern to make this easier, this uses that design pattern to make this easier, which makes this easier. You get that kind of long chain of requirements, and it blows your code up. Now your code is significantly more complicated, but from the end user's perspective, they have a little bit more that they can do with it. Maybe a one click allows the user to now specify, I want a class with a field. We know the size of the rectangle for the class box now because we know how many fields and methods are going to be there. So instead of needing to implement resizing the class box to fit more fields and methods on creation, we can draw the exact size that we need because they specified, I want to fill in the 3 field, 2 method class prototype. So lots of design decisions here as we start to move toward introducing design patterns and using some design patterns in this. We will talk about this more as we get there. I don't know if that's going to be as relevant for Thursday. I'll try to come up with something new to talk about. But I at least wanted to do this ahead of tomorrow. So tomorrow's client demo. Be ready for a nice professional interaction with the client and showcase what you've been working on. I'm sure he's very excited and I'm very excited to see what you've been working on. So I will see you tomorrow for that. Remember that you don't have to have all of the functionality done, just enough to be able to say, is this usable? Be able to determine the usability of your program. All right, I will see you tomorrow for that.